Hello, welcome to the WDBE partner session on DiCtion, Digitalizing Construction Workflows. My name is Olli Seppänen. I was the principal investigator in this project that is supported by Business Finland and a consortium of 8 companies. Today we are going to hear about situational awareness. I will first describe what are the gaps and what is the current status. Then we will hear about what are the obstacles of implementing situational awareness, what is the role of ontology in making this work, and then we have a case study of 4 companies integrating their solutions using the ontology developed in this DiCtion project. First of all, what is situational awareness? We define it in this way. We have some kind of plans and change tracking, and earlier digitalization has focused mostly on the blue side. Then we have the actual situation in project environment, the green area. Traditionally, people have been making perceptions and observations manually based on this actual situation, for example, by taking notes about what is going on site. These perceptions have been stored in human memory and socially distributed in meetings. Now with technology, we are getting new alternatives how to get situational awareness, and we call it digital situational awareness. We have sensors, we have cameras, we have all kinds of technologies that can be integrated, and situational data can be collected automatically. And this can all be saved to computer memory and automatically distributed. So now we have developed technology. There are sensors, there are positioning beacons, machine vision. We have simplified process. Big companies are implementing prefabrication and tagged production, and digital engineers are collecting digital data. But whenever we measure situation picture, we don't see that pretty results. For example, here you can see that when we measure how much the workers are in work locations, they spend 52% of their time in work locations altogether. But if you measure the time they spend in work location without interruptions, and they have to be present for 10 minutes in the work location without going away, we get down to 34%. So only 34% of the time people are able to work without interruption in construction sites. When we look at whether they are in the correct location assumed in the plan, we get around 50% of the time. So out of this 34%, 50% of the time is where the plan is assuming the people would be. So we get a track record of 17%. We have defined a couple of KPIs based on this uninterrupted presence. The first one is presence index, which is uninterrupted presence in a task divided by actual duration of the task. Out of all of our measurements, we get 34.5% average with large variation. And variability, of course, is the root of all evil. When we measure the presence to plan ratio, so how much uninterrupted presence you need compared to what you planned, we get 33.8%, which means that there's an opportunity of 60% in compressed durations if we can reduce interruptions. Only 1/3 of the duration is needed to actually do the work. This basically means that we need to get rid of external variability. It's not enough to digitalize the construction site, but we need to figure out also all the other supporting flows connected to the construction site. So based on uninterrupted presence, we are basically measuring how much of the time the worker is present in the work location. So we are measuring optimal productivity, work method, skill differences, standardization. These are in the 35%. That's the only thing that is within the scope of control of the worker and the subcontractor in question. The remaining 65 to 70% is due to external factors. And the solutions we are going to present today are related to measuring and improving the external variability, which is where we should start because it explains 70% of the workers' productivity. And next we go to the actual solutions. Okay.
Thank you. Thanks, Olli. And now we take a direct cut to the site, and I'll show you where we are and what needs to be done next. This is how the success looks like as of today. We have the situation picture, fine. It is available in real time on site, so the site manager can use it. It is available on weekly meetings, in scheduling, in subcontractor meeting, in internal meeting, and it is always accurate. And what you can see here is the conditions on site, who is present. We have the schedule, tagged schedule here, and then PPC figures, etc. But it is always mandatory that the site so that the data is accurate. That means that foreman has to update the data daily basis on site by using the mobile apps. Well, that's good. We can be for 5 seconds satisfied where we stand now. But still, the TACT shows us that there are plenty of variance in everyday life, so the TACT actually is not intact. What I mean by this is that we are implementing the subcontractor management model. We lead the work on site. We have the scheduling software in which we assign tasks for certain time slots for certain subcontractor and their workers. We receive from the site the acknowledgements when the task is started, finished, etc. A very important part is the roadblock management, so that the subcontractors let us know immediately if there is something what prevents them in implementing the tasks, and then we can have the half of the footprint of the duct production. But the main thing is finishing the tasks, so we have to have the quality management in place, and we have to have applications by which we can check the data, check the sites, update the data, etc. directly on site, so that we enable the real-time situation picture for the site office. And this is good. This is what we have done in 2 years. So the external variance exists still on site, even though we manage the events, the task management on site. Still the problem is that the external world is causing problems to us. So where we started, we had in the beginning, 3 years ago, we integrated the quality and scheduling software, got that to common database, and then visualized that with Microsoft BI. And with that we gained the dominance for the one single project on site, and that was good start. But the next step we took was change from the closed database to the platform. We moved with Google. We got very powerful equipment for the data management, and also we started to integrate more and more applications, data sources, and continued the visualizing with the business intelligence. This took us to the second stage or second generation, where actually we managed to provide the data from the production to the business unit. Business unit meaning the management for whole housing department, for example. So we extended the platform to number of projects, but still we are tackling with the external variance or variability. And this is the step we have to take together. We have to move on, include the business process, business and process logic and projections. So that is actually the intelligence what we are aiming. But before doing that, it is mandatory that we provide the standard interface to the platform, and that means that the whole industry must overtake the GS1 as a standard, because if we don't do that, then every main contractor has to set up their own open databases and integrate by themselves all the applications and provide them to the material providers, prefabricators, logistics. So in essence, we have to take the next step together as an industry so that we get rid of the solutions which are developed by each individual main contractor and have a united and common interface by which then we can connect the existing platforms, existing data sources once and for all for the whole industry. So this is what we call open integration platform, what we aim, and GS1 is the takeover or takeaway for home for everyone from this presentation. Thank you.
Hi, I am Rita Lavikka, a senior scientist at VTT, Technical Research Center of Finland. I have had the pleasure to be involved in digitalizing construction workflows in the DiCtion research project. Construction is often project-based business where a new type of product, often based on competitive bidding, is being built through a process negotiated by the project parties not familiar with each other. Each company, naturally, works to suit its specific interests and thus optimizes its processes based on these interests. In this kind of an environment, transparency of operations is required to enable collaboration. Implementing digital tools on site will result in greater transparency. Digital tools provide us with situational awareness, which tells what has happened, what is happening, and what will happen in the project. Unfortunately, many of the current contract forms are not transparent, and thus digital technologies are often opposed by parties who feel that they could reveal mistakes and make project parties more vulnerable to claims. Some companies even have business models that are actively benefiting from the lack of transparency, especially in the traditional design-bid-build environment. New digital tools have been implemented fastest in contract forms such as alliance and integrated project delivery, which require transparency. In other contract forms, it looks like the owner must have an active role and require greater transparency for digitalization to happen. Trust is a key prerequisite for creating digital situational awareness, which necessitates the sharing of data between project stakeholders and documenting the whole site with images and also recognizing the activities of workers. Even though digital tools can provide us with transparency, opportunities for misusing data exist. Today's construction processes are based on blaming others for mistakes, but with situational awareness, the real root causes of problems will be revealed. Thus, all mistakes are visible and cannot be easily explained away. Transparency enables continuous improvement, but can also be used to attack the party who made a mistake. If technology is used in this way, there will be massive opposition. The same applies to the relationship between construction tradesmen and employers. If situational awareness data is used just to increase supervision on site, and workers do not get the benefit, labor unions will start to actively oppose the new technologies, such as resource positioning and machine vision. As a result, there is potential for all parties to benefit, but there is a big risk if technology is used without win-win business models. Lean construction can help in the implementation of digital tools, since Lean aims to improve processes continuously. Lean involves the supply chain in long-lasting partnerships and values the workforce. Situational awareness will benefit all parties if everyone changes their behavior from optimizing only own processes towards optimizing what is best for the project. Alliance and integrated project delivery projects are the best collaboration platforms for creating a win-win environment for each party. Everyone should be able to create, but also capture value in the project. The development of win-win business models requires understanding other parties' motives and revenue models. It is necessary to define how parties behave with the traditional business models, which we call Construction 1.0. After this understanding, we can envision how parties would behave with digitalized workflows and situational awareness, which we call the Construction 2.0. Future study methods, such as scenarios, are important since they give us understanding on the systemic changes, so that we can envision how digitalization will affect different parties and what is expected from each other in terms of behavioral changes. Peer pressure might help us drive change. However, collaborative contract forms would benefit most because they already increase trust between project parties. Thank you.
Okay, my name is Seppo Törmä. Good morning. I'm from VisuaLynk, and I'm going to talk about digital construction ontologies. This work has been done in two collaborative research projects, DiCtion, which focused on development of a shared situation picture for construction, and BIM for EEB that deals with BIM-based renovations. And the common theme in both of these projects has been the integration of heterogeneous building data using ontologies and linked building data technologies. And we have developed a set of ontologies called digital construction ontologies, and we have published them on the web. There is full documentation available about each different module of the ontology, and there's also the source code of the ontology available. And the ontology is pretty broad, and it covers the different entities in the construction domain. So there is the central ontology is called the entities ontology, and then there are further ontologies that specify different kinds of activities and processes, different kinds of agents in construction, and information content entities that appear in construction and renovation projects. In this use case, we have actually mapped this ontology to the data that's produced by the different companies. There are categories of objects. There are agent categories, object companies. There are delivery activity belonging to the category of activities. There are locations, there are material batches, and then there is an issue that is a quality issue that is detected in the in this use case. And then there is a example of objects that that belong to these different categories in this particular use case. Thank you.
Hello, my name is Viitanen. I'm coming from the company called Carinafour, and I will show the short demo of our system called CALS, Carina Assembly and Logistics Service. So actually, shortly, Carinafour, some 8 years old company, 14 million euros, 100 workers, tag-based production and logistics since beginning, big customers in shipbuilding and constructions. Our job is to actually take care of the material flows and enable continuous workflow. And if we go very simply through that, how are the basic elements in production and logistics in the value chain. So the production, it's easy to run if you have the work instructions, resources, materials for the work tasks, then the progress-based scheduling. And our job is to handle the logistic part, provide the materials to the production, and then we need the information, location-based material lists, material availability tracking, and then the material identification. And we need to be contacted based on the same scheduling, which is running the production. And the idea is that we have the tag production, work phases, and then we have the so what we are calling work packages per work phase or per tag, and then we have defined the material lists per tag. And then we are managing the materials from the design stage to the procurement and logistic until the material is in the point of use and installed. And we are also managing related scheduling, weekly level and daily level. And how the system looks like, we are maintaining and creating the project data so everybody can configure the own company in the system, establish the projects, establish the materials, and then attach the different attributes to the materials, like CO2 or like dimensions or the instructions or the working hours needed per unit or the team who will install it. And then they can link the vendors as well, where they are willing and what vendors they are willing to use for the materials. Then actually how to create the site and all the other locations in the system. So here we are establishing the sites and defining the floors, defining the flats, and these informations could be also uploaded from another systems where those are created or established before. Then in the system we are creating so-called work packages, the pickings, where we are picking the materials to the baskets, giving the destination, giving the time, and then managing the baskets. For example, here the flat number 101 in the address here, and then we have the picking and the picking items under it. And then when we need when we recall the material, first just we defined it, and when we're recalling it, we can recall it a couple of days before directly to the point of use. And then we are actually the sender, they are doing the pickings and packings in our system. And then we have here the actual example that we have the material package where we have the damaged material, and the damaged material we can actually get, for example, from Congrid, another system, the quality system, and we can actually ask the replenishment from the hand buffer and move it to the flat where it is needed, and then we can ask to get the hand buffer material, replacement material afterwards, so we can maintain the hand buffer level. And all these material movements, they are in the system. And all these the material replenishment orders, they are they could be run automatically when the minimum level has been reached. So this was more or less my presentation. We have the material management system, which is talking together with the scheduling system, quality system, and then we can also give the information from our interface to the reporting and situational awareness systems like a Fira control room, and then we can also utilize the same information together with Aiforsite, the systems where we could get the wide data to analyze how the project went and how that should be improved further, and where we have the bottlenecks to improve. So more or less shortly, this was my presentation, and we are focusing at Carinafour to the material management. Construction is assembling process, and in all assembling processes we should manage very carefully the material flows. Thank you.
Hi, my name is Timo Makkonen from Congrid, and I'm telling about quality assurance and defect management related to this case. So we've been talking about the delivery of the gypsum board and how the materials are handled, and my part is to tell more about the quality assurance process and the defect management and how it's handled now and what is the future possibilities to do the defect management and quality assurance. So current state is that we can follow quality assurance on the work section level and by apartment. So we can have different work sections like a gypsum board installation, and it can be divided on the different subsections. And we also have locations like apartments, which is illustrated here, and like in the Ari's presentation as well. So we have harmonized the data between the systems. So any inspection or defect found from the system can be linked to the certain work phase or the certain location. But we can do this on the item level, as we have systems discussing with each other, so we can link also the BOM level items to the actual inspection scheme. And for example, if we consider that we have one installation ongoing, and we start the installation by accepting the site, for example, we can link with that inspection that we have started the work, we have received the material, we can read the item, plus we can also, now I'm losing the word, trigger the next delivery to the next work phase. So we know immediately after we have made the first inspection that we have the material in place and we can ship the next material. And that can be done together with the systems discussing with each other. Plus, we can also fix possible defects before we are moving forward. So we are improving our process bit by bit when building proceeds. So the defect which was found in the first place, not gonna repeat on the second building, or the second apartment. So we improve the process and we can put the information moving between the system. And what does this mean on the system level? So we have this demo project at Hukkatie 5. It means that we have the basic information aligned with other systems. So we have the same project, same companies, plus we have the same areas, and we can also have the same items in all the systems. So we follow the data between other systems. And to the quality assurance point of view, we have aligned all the work sections and all the inspections made on the site. Plus, we can also follow the defects on each systems transparently on the web and on the mobile, such a way that it's available on the site and in other systems. And now we have the situation that the one gypsum board what we received is broken. So at the site, we will record it on the mobile device, take a picture, mark it where it was, and we can link it directly on the BOM level, meaning that the specific item, the gypsum board, is known that that was broken, and we can decide whether we're going to take like a spare supplies or from the apartment number 2 supplies to fix that one. After we mark the defect, everyone gets the notification out of it, meaning system-wide and the person-wide, so the installation parties plus the suppliers know that okay, there's a broken gypsum board, we need to fix that. And when we have possibly delivered new board, we have documented the replacement delivery or the possible fix, for example, plastering the board if we decide not to deliver a new one. And with that, linkages between the systems, information is shared between the systems, plus we are building the as-built model as we build the actual building. So we collect all the data from different systems, and in this case it's inspections and defects, and the other systems fulfill the package. So when we've finalized and make the handover, we have the as-built model in place. Thank you.
Oh, hello, this is Tommi Vihervaara speaking. I'm acting as a head of data for Fira, which is a construction company for a new era. Today, along with our 4 companies together here, I'm speaking as behalf of Fira, and I'm gonna tell you and show you how to leverage digital solutions to smoothen the construction process, and the main thing in our presentation being how to use ontology in practice. Here we have the concrete example what can be achieved with proper master data management in Fira. So in every construction site that we have, they are at the moment having a more and more digital footprint that comes from the digital solutions they are leveraging at the sites. In the picture and in our concept site situation room, we are pulling the data from 6 to 7 different systems real time and putting it on in this real-time dashboard. And this is the core, let's say, deliverable what comes out when you are properly defined your ontology, define the entities, data entities that you're leveraging, and this is the, let's say, trick how to put them together. Common ontology. And how does it look like? Very simplified version, but being a construction, working with construction, you can see there are in the corners, you have the typical areas of, let's say, construction site management, the conditions, quality management, schedule management, and of course the logistics and supply chain management. In a way, 4 or even more different islands separate from each other, but this is the trick. How to put them together is to have a common language and, in this sense, common master data layer in between these 4 separate islands of data. And the core entities there is, of course, space and location. You need to define in common language that we are talking about this very same apartment number 101. And you need to, when you start the construction project, you need to know in which work phase or work section you are talking about. You need to have common way to emphasize the work sections as well. And of course, speaking about materials, products, you need to have also common standardized representation for that as well, so that you can build and, let's say, for example, bill of materials along with the construction work going on. And when you properly define these kind of things and put them into this, you will end up having, as I said, these kind of, for example, real-time situation view, what's happening on each distinct construction site. For example, our common example in Turku, Finland, we have this site in Hukkatie 5, where you have actually this incident that there is this broken Jaipur plasterboard, and actually the moment that it gets entered in the Congrid quality management system, at the same time it instantly flows into our data arc that we leverage behind this dashboard, and it can be seen on the dashboard. And actually users can go there and click and actually jump into the details, but at the same time they can see how does it affect in the terms of schedule and other things. And the next big thing is to leverage the whole, also this idea to how to show the details of the specific plasterboard material there, and this is something that we will see some nice results from upcoming months and years. So this was a brief example how to leverage ontology work in practice and make the digital solutions even more effective and working together. Thank you.
Hello, my name is Pyry Virrantaus. I'm Chief Operating Officer at Aiforsite, and today I'm going to give you a case example regarding how we can use situational awareness and various applications to track delivery of drywall package. So it's very important for us all to enable tagged production, and we have various means in terms of technology to do that. In this particular case example, we can really understand why it's very important to have a common data ontology in order to standardize and integrate the processes. So starting from the right hand side here, so in this example we are tracking a drywall package, and this specific package is assigned for a specific tags, and we start from the logistics center. So at the logistics center we prepared for delivery, and first we started so that we log it into Carinafour's CALS application, and then we label it with Arico code, and that particular code is read by Aiforsite AIC's AI engine, and we utilize cameras for that. And then we also attach position tags so that we can later understand where the package is traveling at the site. Then we move forward from the logistics center to the actual construction site, and now we identify the particular drywall package at the site as follows. So we read the code utilizing Aiforsite's AI engine, utilizing cameras, so that will automatically identify that the package has arrived at the site. Then we also update that information automatically to Carinafour CALS, and we also gain the benefits of having the full situational awareness of the whole site utilizing Aiforsite solution. And also from the construction site management perspective, it's very important to manage the whole schedule, and Fira Site Drive is a good tool for that. So moving on to the next part. So then what happens when the drywall package enters the identified tagged area? So once again, the code is automatically read by Aiforsite system, and then it means that all the various systems can be updated accordingly, so that the installation can take place at the site. In this case, there might be a situation where the drywall board, a particular board, is broken, and in this case it would be quite natural to make that observation also utilizing smart systems like Congrid for quality defect management. And in that case, Congrid will also discuss with Carinafour's CALS to make sure that the order input is updated. And once again, that also can be managed by Site Drive in terms of scheduling. So the point here is that in this example you saw various applications to be used. You have various data sources, and in order to standardize and integrate this whole thing from construction site management perspective, it's very important to have a common data ontology. Thank you.
Okay, we have now heard why reducing external variability is important, what are the gaps in the current state of the art in order to decrease the external variability. We have seen solutions from 4 companies that target to decrease external variability by integrating their solutions through a common data ontology. We have Carinafour, who is aiming to handle the material logistics part of the picture. We have Congrid, who are responsible for quality management. We have Fira, who have a scheduling solution and a control room. And we have Aiforsite, which is aiming to bring all of these together into one common platform and provide situational awareness through various data sources. All the members of the presentation team are here now, so we are ready for these questions and answers, which you can submit in the chat window, and we will address them. We have 20 minutes for discussion. Thank you.